Okay, here we are given a jumper. So you are told that the jumper has to jump into the air as high as he can. The mass of the jumper is given 70 kg. The height of the platform is given 80 meters. And the length of the unstretched rope is given also 40 meters. Then in the diagram 8b, the jumper jumps up into the air with an initial velocity of 5 meters per second. Okay, so that is my u, which is 5 meters per second. Okay, before we move on, it will be good to define our sign convention. So it doesn't matter whether you take upward positive or downward positive. So let's take upward positive since the jumper jumps up. Okay, so upward positive, then my u will be positive 5. He reaches a maximum height of 81.5. So from the platform to the maximum height, the jumper actually have to go up. And this distance here, right? You take 81.25 minus 80 will give you a distance s of 1.25 meters. Okay, this s will be positive because we're taking upward positive. Then you're asked to find the time he takes to reach the maximum height. So let's take a look at what we have. We have the initial speed, which is 5 meters per second. We have the displacement of the jumper, which is 1.25 meters. We also have the acceleration. The acceleration here is due to gravity. Gravity is acting down, so the A will be minus 9.81 meters per second. Okay, recall we're taking upward positive. Gravity is always down. That's why it have to be negative here. Okay. So from here, I want to find time. Which equation can I use? Okay, good. I should be using s equal ut plus half at squared. No? Okay, then what equation should I use? There's one more info that you have actually. What do you know about at the maximum height? At the maximum height, the velocity is actually 0. That's why the jumper is not going up any higher. So if you know v equals 0, you actually can use a simpler way to do it. That is v equals to u plus at. Okay, you can still use s equal ut plus half at squared. You can still get the same answer. Okay, so you can try that. I'm going to use v equal u plus at. So my v will be 0, my u is 5, my a is minus 9.81, and my t here is unknown. So to find t, okay, make t the subject, I'll end up with 5 divided by 9.81. Notice that your time have to be positive. So when I bring this term minus 9.81 over, it becomes positive 9.81. It makes sense, right? So you will end up with the answer 0.51 seconds. Okay, let's move on to part B. Okay, part B, you're asked to find the time he takes from the maximum height. So now it's from this point to where the rope just becomes straight. Okay, so let's assume that it's here that the rope becomes straight. So the displacement will be downwards. Okay, so the total displacement will be this 1.25 plus the 40 meters of the rope. So the total displacement, which is downward, we can continue to take upward positive. Okay, or if you like, you can change your sign convention. But to avoid confusion, I will just take upward positive. So the jumper is going down. That is to say that the displacement will be minus 41.25 meters. Okay, what else do I have? So at the maximum height, I know the velocity is 0. Okay, so I will call this u now, because what we are interested is from the maximum height to this new height. So the starting point now will be my initial velocity, which is at the maximum height. So this u will be 0. Okay, acceleration also I know because it's due to gravity. Again, it will be minus 9.81 because we are taking upward positive. Any other info that we have? Do we know the v? No, we do not know. Okay, because when the rope becomes straight, the velocity is actually at its maximum value, but we are not given. So I want to find t. Which formula can I use? Okay, yes, I can use s equals to ut plus half at squared. So my s in this case will be minus 41.25. My ut will be gone because u is 0. Then this will be half times a, which is minus 9.81 times t squared. So notice that there are negative sign on both sides, right? So your t squared will end up to be a positive value. So we take 41.25 times 2 divided by 9.81. Your time will be 2.9 seconds. Here you have to reject negative time because time can never be negative. Okay, then we move on to part C. Part C, you're asked to find the velocity of the jumper at this point. Okay, this point refer to when the rope just straighten, right? When the rope just become straight. So we can make use of the previous info we have, and we can use the equation v equals to u plus at. So at the maximum height, the u is 0. The acceleration is minus 9.81, and the time taken is what we have obtained just now, right? So the time taken is 2.9. So multiply by 2.9. So 9.81 times 2.9, that will give me a value of negative 28.4 meter per second. Okay, the value for velocity here is 28.4. The direction is going down. Recall just now we are taking upward positive because the jumper is going down, so the velocity have to be negative since the jumper is coming down and we are taking upward positive.